welcome back to Chemistry TV. Now let's look at calculation of pH of a buffer solution. We have three questions here that I will solve in this video here. Now by the end of this video, I should be able to solve some basic problem when it comes to when it comes to calculation of pH of a buffer solution. Now I've done some videos. I've done derivation of the Henderson-Hasselbalch equation, because the formula you can use to calculate the pH of the solution is called Henderson-Hasselbalch equation. And if you are going to do a theory question when it comes to acid and base, they're going to tell you to derive the Henderson-Hasselbalch equation in your buffer solution. So you must know how to derive the Henderson-Hasselbalch equation, because they are going to ask to derive the Henderson-Hasselbalch equation in your exam. So if you don't have to derive the Henderson-Hasselbalch equation they can use to calculate the pH of a buffer solution, then go check out that video. Do you understand? Because I've done a complete video on that. So let's look at the formula again. The formula for calculating pH, pH equals what? pKa plus log A minus what? HA. Either. So where this is what? Is the acid, and here is what? Is the base, conjugate base. Either. So no matter if the buffer solution is acidic buffer or basic buffer, always understand that base must be here and acid must be here. Do you understand? So this is what we want to use in our calculation here. So for each question, you have to detect. For each question here, you have to detect what was given to you. Do you understand? Or what is given to you. So let's look at what the first question here. Say I calculate the pH of the solution containing 0.1 acetic acid. Now this is the acid here. Just as I said, HA is acid. So concentration of HA, which is what consists of the acetic acid, right? CH3COOH is equals to what they say is what? 0.1. Do you understand? 0.1 molarity. Now and 0.05 sodium acetate. Sodium acetate is what is base. It's called conjugate base. Or conjugate salt, which is what? A minus. Do you understand? So when a question is being given to you, you must identify what base and what acid. So that is concentration of A minus is equal to what? Concentration of what? Sodium acetate equals to what? They gave us to be what? 0.05 what? Molarity. Do you understand? Now and they gave my pKa. pKa is equal to what? Is equal to 4.74. Do you understand? Now they say she will calculate the pH. So once you something like this here, you just have to apply the formula straight and get your answer. As this that's going to be pH equals to what? My pK is what? My pK is what? Is 4.74 plus log. My A minus is what? 0.05 over what? At 0.1. Do you understand? So what I want to do here is what? Log 0.05. We have 4.74 plus log 0.05 divided by 0.1. So going to be pH equals to what? 4.439. As this is that. So now when put like this big image, just to detect the conjugate acid, the acid, the conjugate base, the pK and this, and what apply a formula here and solve the answer. So you can see how easy it is, right? You don't have what difficult here. So now if you look at the second question is a little bit difficult. So let's look at what the second question here, because the second question is slightly different from this question here. Now before we solve the second question, let's solve the third question. I want us to solve the third question together. So the third question, the pH, determine the pH of a solution containing 0.1 ammonia and what? 0.05 ammonium chloride. Do you understand? So this is called basic buffer. Do you understand? This is called what? Basic buffer. This is what you want to know here. Now I calculate acid buffer and basic buffer that say you're also using what the Henderson-Hasselbalch equation in your calculation here. Now, but you have to do some little changes when it comes to that one here. Now, concentration of the ammonia NH3 is the base. Just and this is the base. Just and so is what is the concentration of what A what minus. Just and ammonia is a base. Here we're going to be the base. Understand this here. So which is going to be equals to what 0.1 what molarity. Just and now and 0.05 molarity of ammonium chloride. Ammonium chloride is the what is the acid. Just and do you know the reason why? Now let me show you something here. Remember, if ammonia react with water, just what is going to produce here? You're going to produce what? NH4 plus, which what is the acid, plus what? OH what minus what? Just so here we have base, here we have what acid, here we have conjugate what acid, and what conjugate base. Conjugate what base. Just now this guy will not serve as acid, here will not serve as what as base. That is what you want to take note here. You understand? So the acid will only serve as the acid, while the base only serve as what as base, because you are using what this pH here. You are using what the necessity by equation. You understand? So that is my NH4 plus is equal to what? The what HA, which also the same thing as what 0.05 what molarity. Do you understand? Now, here they say ammonium chloride. Ammonium chloride, if you look at ammonium chloride here, NH4 plus Cl is what? NH4 plus Cl what? Mind, do you understand? So this and this are the same. Sorry, NH4 Cl. Do you understand? So NH4 plus is also the same as what? NH4 Cl. Do you understand? So that is what is my acid here. So we don't understand here but here's the problem here. Here they gave me what PKB. Do you understand? They give me what PKB. Now remember, if I want to solve here, I must calculate what pKa. Do you understand? I must do what? I must calculate what pKa. So now there's a relation between pKa and PKB. pKa plus PKB is equal to what? 14. You have to understand Ka plus PKB is equal to what? 40. That is the relation between pK and what PKB. Now, when I use formula here, you have to what? Know your pKa. But the question gave me what? pKa of what? Of the ammonia, just which is base. So from here, now I can use this formula here to calculate what? To calculate the pKa. Just so make it pKa the solid formula here. Here I have pKa equals to what? 14 minus what? PKB. Just so which is going to be what? We're going to be equals to 14 minus what? 14 minus the PKB is what? 4.74. So subtract it here. 14 minus 4.74 is what? 74 is 9.26. Just 9.26. So that is going to be what I pK. So my pK now, I'm using pK is what? 9.26. So I want to wipe this place out. So now let's apply our formula here. pH equals to, now my pKa is what? 9.62 plus. Now log my A minus, which is what is the ammonia here, is what? 0.1 over what? Here we have 0.05. You see that? So here we have 9.26 plus log 0.1 divided by 0.05. So you're going to be pH equals to what? 9.56. Do you understand? That is the answer. Now you can see that this is what basic buffer. If you check this basic buffer and the pH is more than what? 7, which is correspond here. Do you understand? So this and this one look alike, but here is acidic buffer, so it corresponds. But from here you need to make some little what adjustment. Do you understand? So let me to what question number 2 now. Let's see how we can what answer question number 2, which is a little bit technical here, because they say that a paper holds 0.20 HA, which is the acid, and 0.15 Al salt, with a resulting pH of what, 3.35. What is the pH after 0.015 mole sodium hydroxide is added to this solution of 0.500 liter volume? So now, how do you answer this question here? This question is a little bit technical, and it's going to take us a little time for us to solve. Now, what I want to here we have concentration. They give a concentration of what, they give a concentration of the of HA, right? Which is the acid, weak acid. Here we have concentration of HA is what, is 0.20 molarity. Do you understand? And they also give a concentration of what, HA, A minus, we call conjugate base, is what, 0.150 molarity, right? So now, the volume of the buffer solution. Now, this is the volume of the buffer solution. You have to understand this here. This is the volume of the buffer solution. So volume of solution equals to what, 0.050 liter. Just now they gave us mole of base that was added. Just a mole of base that was added. So mole of what, NaOH is equals to what, is equals to 0.0015 mole. Look at something here. Do what you want to do here. Therefore, you have to calculate the mole of this guy and this guy. Just now, because this is the mole here. Because now, when a base is added to a buffer solution, now what is the buffer solution again? A buffer solution resists the change in pH when small amount of acid or base is added to it. Just now, so when small amount of acid is added to a buffer solution, it can resist what, change in pH. Now, the main reason why a buffer solution can resist change in pH is because every buffer solution have acid and base. Do you understand? So when an acid reacts, when an acid is added to what, to the buffer solution, what happens here? Now the OH, the what, base, the base component of the buffer solution will react with the acid to neutralize it. Do you understand? So when an acid is added to a buffer solution, when a base is added to the buffer solution, the acid component of the buffer solution will react with what, with that base to neutralize it. Do you understand? So that is the reason why the buffer solution can what, resist what, change pH, because the buffer contain both acid and base. So anything you're adding, they have to react with it. Either acid, either the component part of the acid, or the basic component of the what, or the base component of the buffer. Do you understand? So these are things you need to understand here. So if a base is added to a buffer solution here, it's going to react with the acid. Do you understand? Now, and as it's reacting with the acid, because a base, because this is a base, conjugate base, this is a base that is added. This is strong that is added. So a base can never react with the base. A base will react with the acid. Do you understand? Now, when a base reacts with the acid, it's going to decrease the concentration by its amount. Do you understand? It's always going to decrease the concentration by its amount. Now, at the other hand, as it decreases the concentration, you're going to increase this one here. Do you understand? But here the problem here. Here I have molarity, here I have molarity, here I have mole. Now, for me to be able to what, subtract from these, I must convert this one to what, to mole. Do you understand? So remember, molarity is equal to what, mole over what, volume. Do you understand? Mole over what, volume. So let me calculate what the mole. If I should make mole the soil formula here, it's going to be mole equals what, molarity times what, volume. Do you understand? So what will happen here? Going to be mole. So going to be mole of what, HA. So mole of what, HA, which is the acid, is equal to what, the molarity, which is 0.20, 0.20 minus, or times, times what, the volume. The volume is what, 0.50 what, liter. Just 0.50 what, liter, which is liter, right? The same thing here, mole of what, of A minus is equals to what, 0.15 times 0.50. Do you understand? So let's push our calculator here. So here we have 0.20 times 0.50. Here we have 0.1 mole You have 0.15 times 0.50. Here we have what? 0.075 mole. Do you understand? So these are what my mole here. You get now from here now. What am I going to do here? I'm going to subtract them. So I will wipe this out. Let me wipe this out so I can use to solve here. Now let me ask you here. Why are we converting the concentration to mole here? Now the main reason why we are converting concentration to mole is because the mole of sodium hydroxide that was given to us. So it must be more and more, so I can subtract all of them together. Do you understand? So now these are now my moles. These are what my moles. These are what are my moles. Do you understand? So my mole here, please pay close attention here. My mole here. So how do I look for the mole, the new mole? Now because when this one was added, you are now going to get a new mole. Just as you get a new mole. So you are going to subtract this one from the acid, just add this one to the base. Do you understand? So now whenever you're adding, look at something here, whenever you're adding the base to a buffer solution, the base, you only subtract that amount from the acid, they add to what the base. Do you understand? So mole of HA is what? Is going to be what? 0.1 minus, here we have 0.0015. 0.0015. The mole of what? Mole of A minus is what? 0.0075 plus 0.0015. Just now, why are we subtracting this one from this one here? Because it's a base that you added to it, and the base will react with what? With acids. And if this base is reacting with the acid here, it's going to what? Subtract it. So that's why we are subtracting. Do you understand? The same thing here. Whenever a base is added to a buffer solution, it's going to increase control of base. Do you understand? So that we have some here. So here we have 0.1 minus 0.0015. So we're going to be 0.0985. Do you understand? Same here, 0.075 plus 0.0015. So you have 0.076. Do you understand? But here, remember they are moles. They are what? They are moles, right? Now, yeah, you have to use what? Their concentration. You have to use what? Their concentration. So you have to calculate their new concentration. Just you are calculating what their new concentration. So how do you calculate new concentration? Remember, concentration so going to be new concentration, which was HA is what? Mole over what? Volume, right? So my new mole now is what? 0.00985 over the volume is what? The volume of the solution is what? 0.50. 0.50. Just the same thing here. A what minus equals to what? Which is 0.076. 0.0765 over what? 0.50. Do you understand? So want to punch your calculator here. Here we have 0.0985 divided by 2.5 equals to. So here I have 0.197. Same thing here. 0.0765 divided by 0.50. Here we have 0.152 what? Molarity. Do you understand? So this is what I'm now going to use in the calculation. Now, there's a problem here. They did give what? The pK. So the pKa is what? Is 4.74. Now, whenever this kind of question be given to you, the pKa will always be given to you. Do you understand? Since you have gotten this one and this one here, so can I use this our equation to get our pH? You know, right? Now, my pK is already 4.7. pK is already 4.74. Do you understand? Now, it's a question they will not be giving, but here we are being given. Do you understand? So, if you are not being given the pKa, obviously you have to calculate it. You understand? You have to do the calculation using the pH, the initial concentration of what? The acid and what and base. You get to calculate what your pKa. But here it have already been given to you, so you don't have issue with that. Just now. So now what I want to do here is this. You now apply the formula here. pH. Remember, pH is equals to what? My pK is what? 4.74, right? Plus log A minus, which is what? The conjugate base here is what? Is 0.153 over. Now, for the acid is what? 0.174, right? 974. 97. So, what I want to do here is to bring out your calculator. Now your calculator. So, I have what? 4.74 plus log 0.143 divided by 0.197. So here I have my pH now. My pH is what? 4.630. Can you see that? Now this is what I want to explain here. Remember, this is the pH after you have added what? The base to it, right? Now, my initial pH was what? My pH was 3.35. Can you see that? Now, what does this tell you here? Now, whenever this is what you need to understand. Now, whenever the base is added to a buffer solution, it always increase the pH of that buffer solution. Do you understand? You need to take note of this. But whenever what acid is added to a buffer solution, the pH always what decrease. So these are things you need to take note of. So I believe these are stuff you need to master when it comes to what calculation of what pH of a buffer what solution. All this video is helpful. Please, if this video is helpful, leave at the comment section. This video is helpful. Yes. If you have any questions, also leave it at the comment section too. If you don't know how to derive the Henderson-Hasselbalch equation, please kindly go watch our video on derivation of the Henderson-Hasselbalch equation, because we're going to see question on that. See you in the next video.